Hello everyone, today we'll be solving this problem on switch debouncing. The course is microprocessor and embedded system. We will be solving this circuit. We will be finding the values of resistance and capacitance, and we will draw the circuit again by inputting these values onto this circuit. So this is the actual circuit. So first let me give a brief description about it. So here's the VCC, here's the first resistance, here's the diode, resistance 2, here's the capacitance, and here's the buffer. And here's the switch. So what happens when the switch is open actually? When the switch is open, the current cannot pass through this path. So the current will simply go through this path. And the capacitance will be charged. So at this point here, at this point, the voltage will be 0.7 volt because of the diode. So as we found 0.7 volt here, it will go through this buffer and the B output will be for 0.7 volt. And the output will be logic 0, and for discharging path the switch will be turned on and the switch will be closed. So when the switch will be closed, just a minute, so when the switch will be closed, the capacitance will be discharged here by following this path. The capacitor will be discharged through this R2 resistance by following this path, and in that case here the voltage will be 0. At this point the voltage will be 0 volt, and at the output it will be logic 1. So this is the main fundamental concept. That's interesting thing, this diode, if we don't use a diode here, the path for capacitor to be charged will be from VCC to R1, R2, and then capacitor. The R1 value is much higher than R2. Actually, it will take too much time for the capacitor to be charged. So that's why we choose a diode to short the time for the capacitor to be charged. In real scenario, the R1 is much higher than R2. We will see the actual results in upcoming part. So let's start. So for calculating these RC circuit values, we have some steps to follow. For better understanding, I have written the steps here. You can just take a snap if you want. That's 4 steps are for discharging, and these 2 are for charging period. So in the first step, let's assume capacitance C1 equals 0.1 microfarad, and then we have to find the R2. So let's go. So for discharging, the formula for finding R2 is R2 equal minus T divided by C into ln V threshold divided by V final. So let's see how can we find this values. At first, let's see T. It's actually the time period. So what's in the problem? Here you can see, here you can see the switch exhibit bounce times well under 5 millisecond, and the duty cycle is 50%. So actually 5 millisecond is not 50%. So what will be the actual time period? It will be 10 millisecond, 100% of it actually. So here it is time equal 10 millisecond. We will be inputting this into this part. And see, we just assumed, here you can see we have said C will be 0.1 microfarad. We will be assuming it for the betterment of our solving. And the B threshold and B final. And for discharging this, just a minute, for discharging B threshold will be the signal going low voltage, going low. And B final is actually VCC, 5 volt. So here let's see the problem. If you focus correctly, you can see that the value is mentioned here. Signal going low is 2.2 volt. So we'll be using it. Here's, you can see the threshold equal to 2.2 volt. And as I mentioned earlier, VCC will be 5 volt. So putting all these values into this equation, we will find R2 equal to 120 kilo ohm actually. For taking an absolute value, we have taken 120 kilo ohm. Then next step is calculate bias voltage V equal to IR2. We just got R2 equal to 120 kilo ohm. We will be calculating it using this formula. And here you can see I is the leakage current, 15 microampere. That is mentioned in the problem. Here the leakage current is 15 microampere. So by using Ohm's law, P is equal to IR, 15 microampere and 120 kilo ohm, we will get it 1.8 volt. Sorry for this issue actually, the value was incorrect in my previous problem. So we actually got a large, a huge value for that mistake. So let's continue to the next part. And then we have to calculate this part. We have to check it. If the founded biased voltage, as we found it 1.8 volt, if the voltage is close to switching point voltage, then change. Oops, just slight mistake. Then change C1 value again. Usually 10x higher. Now we will consider C1 equal to 1 equal 1 microfarad. So here you can see the voltage we found is 1.8 volt. The voltage mentioned in the problem, the switching point voltage actually, here you can see I mentioned it. If the voltage is close to the switching point voltage, here you can see in the problem. I will add a snippet of this problem so you don't have to just look again and again. Here you can see the best case here. Here is best case switching point is of the 0.4 volt. I guess you can see it correctly, 0.4 volt. So as we just got 1.8 volt here, and the actual voltage was 0.4 volt, so it is actually close. So we have to take C1 equal to 1 microfarad, and we will calculate, and we will move to the next step. Oh, another thing, we have to consider R2 value 10x smaller actually. It's not mandatory that you have to take it 10x smaller. Just take a smaller value and calculate it again. So also we have to use this R2. So as we got R2 equal 120 kilo ohm, we will be considering, let's assume, sorry, let me fix the focus. So let's assume R2 equal 12 kilo ohm actually, because in previous part we got R2 equal 120 kilo ohm, so we took a smaller value 12 kilo ohm and C1 equal to 1 microfarad. So it's done. Now we have to find R1 plus R2. We can call it R for charging phase. So for charging phase, R equal, for example, another equation actually, T divided by C into ln 1 minus B threshold divided by B final. As we know, B threshold is, sorry, the B threshold, as we know, T is 10 millisecond and B threshold will be going high. Previously for the discharging we took the voltage going low, this one 2.2 volt. Now we will consider 0.8 volt for charging phase. Let's start. For charging B threshold will be 0.8 volt. An interesting fact, B final would be 5 minus 0.7. Why we are substituting this 0.7 volt? As you can see, there's something mentioned. The silicon diode voltage drop is 0.7 volt. So we'll be considering that voltage also for charging phase. As you see here, the charging phase, there is a voltage drop across the diode. So the B final would be 4.3 volt. And as we took C equal 1 microfarad, so let's put all this into this one equation. T equal 10 into 10 by 3. C would be 1 into 10 by 6 ln 1 minus 0.8 divided by 4.3. So let's calculate it again. Minus 10 into 10 by 3 divided by 1 into 10 by 6 into ln, into ln 1 minus 0.8 divided by 4.3, closing bracket, divided by 1000. We are dividing the value by 1000 actually for kilo ohm unit. We got it 48.57. here you can see. Remember that we have to divide it by 1000 for kilo unit. So what we got, 48.57 kilo ohm actually. So it is actually R1 plus R2. As I mentioned here, R actually R1 plus R2. So R1 plus R2. As you know, earlier we got R2 equal 12 kilo ohm here. So R1 would be 48 minus 12 actually. 36 kilo ohm. So it will be 36 kilo ohm. So done. That was the value. So here you get R1 equal to 36 kilo ohm, and earlier you get R2 equal 12 kilo ohm, and C1 equal to 1 microfarad. So you have to put all this value into the circuit and redraw it. So let's go. So let's draw it. I want to mention one thing. There's a higher probability that this problem might come in the midterm of AIUB spring semester. And please forgive me if I have done any mistake. So I'm just learning, and I just wanted to share this problem with you. Here's the diode. And there would be another resistance. There would be the capacitor. And here's the buffer actually. It's inverting buffer with the B out. So this C1 equal 1 microfarad. R1 would be, what was R1? It was 36 kilo ohm. So it's 36 kilo ohm. Oh, sorry. There's the C1 is equal to 1 microfarad. I'm really sorry, I just by mistake have written it. It is actually 91, it's 0.7 volt. The R2, this is the R2 was 12 kilo ohm. And this is the switch actually. So done. That was the actual problem. This is a B5 board. And this was the problem. And you must have to write the RC circuit and blah blah. So this is the actual problem. Oh, by the way, there another thing they asked, the hysteresis voltage. Hysteresis voltage is the difference between the going low and the going high value. So hysteresis should be actually 2.2 minus 0.8. So it's actually 2.2 minus 0.8. It's actually 1.4 volt. I guess I haven't done any mistakes. So far I have followed the academic slides our university provided. So that was all. Hope it helps. Thank you.